Hello everyone, this is lecture 15 of PTRE 475575. I posted the grades of exam one a few minutes ago, but they were on Blackboard since many days now. I just wanted to double check to make sure that there was no issue with the grading before posting them. And I also noticed that the grades for homework 2 were not visible to you, but they were visible to us. I didn't know that, so I made them visible as well. So I apologize for that. I thought they were. The results from exam 1 were not as bad as I made it sound last time. The only sad thing is that the issues they were pretty common. There was a question with the leak-off test. Pretty much everybody did wrong there. Nobody did it perfect. And then there was another question with the routine type calculations, which a very common error was people took only one thickness, wall thickness, to get from the outer diameter to the inside diameter, which I explained in the last lecture. That was a common error. There was another small issue. Oh yeah, many people misunderstood that question about decision making. It was true or false. And no, we don't take a vote before making a decision on the wellbore architecture because there is a correct answer and a wrong answer. So we just, that's why we bring the expert to give us his opinion, and we take the right decisions so that we take the right decision. But it was only 1 point, so it's not that much of an issue. If you want to see your exam and understand what you lost points for and where, please reach out to Kalu. Kalu is now in Houston for the International Drilling Conference. He's going to be back, I think, on Thursday or Wednesday. He would be available to help you with anything. It's not the end of the world. That's why we do 2 exams in this class. So if you did not so good on the first exam, there is plenty of chance to fix the problem. Plus, we have 3rd homework coming up. We will have 4th homework. We will have 5th homework, a 2nd exam, and then the term paper and the final exam. So plenty of chances to make up. Just make sure you don't do the same mistakes, basically. That's the idea. So it's not detrimental if you didn't do very well on the first exam. I will ask, please speed up the process a little bit with the term papers. So far, only one person really reached out to me with a serious topic proposal, because you need to get my approval so that you start working. The more papers you read, the more of the literature you are exposed to for the term paper, the better the term paper will be. And remember, the money is in narrowing down into a workable hypothesis or a testable hypothesis. So please, this is what we are focusing on. And that's why I want to approve the topic ahead of time. Is not to give you criticism or to make you feel bad or whatever. It's to massage the topic into where it needs to be, you know. And if you have issues finding a topic, reach out to the TA, reach out to me. We may have ideas that you may find interest. And obviously, it needs to be something that you also like, so that you have some motivation, personal motivation in doing it. It should be something that you're going to learn from. It shouldn't be something, an activity that you dread doing. See it as a good opportunity for some easy points. Okay, that another logistic item is tomorrow. I will have to cut office hours short by at 12 and 10. Reason being is at 12:15 I have a meeting I need to be in. And it's a big meeting with like every engineering faculty. They take attendance and I cannot skip it. So it starts at 12:15 local time. So I will cut off the connection at around 12:10. So if you plan on visiting me in the office hours, please do so early, like from 11 until 12:10. There is, let's see, there is an exam in my other class. You guys already had your exam, so I don't think there will be an urgency to meet me. If you want to meet me and you cannot make it tomorrow at a time, please send me an email and we'll arrange something, a private Zoom call or something. So same thing with the TA. Like the TA is in Houston, but once he comes back, he has plenty of time to meet you guys, and you can go over your exam, etc., etc. Make sure you understand what you did wrong. That's the way to move forward. Because don't forget, the final exam would be comprehensive, so it will cover everything. So make sure that you go over. Make sure you understand everything. Okay, so last time, which was a long time ago, we were watching some very nice videos about multi-stage treatments, hydraulic fracture treatments. And we said that these are a little bit more complicated than what we expected. And we started simple and we were getting more and more complex. We saw the simple plug and perf technique. Where is the video? I'm forgetting the slide number. We had the link somewhere from Aaron. There you go. We watched, so it was slide 64. Plug and perf is the easiest one, the more simple one. You plug the stage and then you perforate and you pump the fluid to fracture, etc., etc. Ball activated completions was a little bit more complex. You activate the tracker using you activate the plug using balls, and the balls have to be a specific diameter. The deeper you go, the more smaller the ball would be, so that the smaller balls would go further. And today we will see coil tubing activated completion, which is even more complex. It involves coil tubing, and it can be more, I don't want to say more profitable, it can be more effective. Just like ball activated completions were invented or were conceived after the plug and perf. And it was to solve some issues, make the process faster, make the process more effective in some regard. Same thing with the coil tubing activated completions. No difference. Just like you're trying to eliminate some problems, and with some innovation, of course. So let's look at this video. It's by Aaron. Forgot his last name now, but skip verification. Okay. Okay. Well, let's see. Yep. So Aaron Barton. And yeah, if you cannot hear it online, I provide you the link so you can watch it on your own. I don't know if the voice is coming through the screen online, but I'm gonna play it now. It's like 5 minutes or 6 minutes. So those are great videos to learn the basics about the process. When this technology was coming out, there was several issues about, well, the challenge was to make sure that the packet doesn't leak or it seals properly to hold enough pressure to fracture that stage. And the frac sleeves were kind of more rigid sort of separation units. It was hard to get a packer to do the job. But nowadays, with technology evolution on this equipment, we are able to hold enough pressure to fracture the stage. But you still hear stories like many times. Even I heard from the Forge project, which is a geothermal project in Utah, that I think is operated by Fervo mostly, and they make the data available online for people, scientists to do projects on those. I would say I heard that there was a stage where they pumped to the highest pressure they could pump, and they didn't get breakdown. So many times the equipment that you are using is limited, and you need higher power, and you are limited by the capacity of your equipment, you know. So it's a common thing. It's not as uncommon as it sounds, having a trouble with a frac stage. And Aaron here mentioned about the screen out, and he gave it a little bit of a different definition than what I gave in class, a more applied definition. But yeah, I mean, screen out is a big problem. I mean, virtually every frac stage ends with a screen out or some sort of a screen out, and you really hope it doesn't happen very early. You know, these are big topics, you know, operationally speaking. And yeah, if you get a job, many of you may get a job in a frac fleet, this is what you are going to be doing. So you are going to go through some specific training that will train you in your company's equipment. Say that you work for Liberty or you work for Halliburton or SLB, and you're going to be doing a frac job. You're going to take the appropriate training on their equipment, and you're going to learn the various stages. You're going to get to the granular level, which is more in-depth than what we are seeing in class. In class, we are focusing mostly on the fundamentals and the basics. But once you go and do the actual job, you're going to be basically a practitioner. You are going to be doing, get to the granular level, understand every step, come up with understand the protocols that are used in the process, etc., etc. So that's with this slide. 3 ways. And there is more. Of course, these are the 3 main ones. And Aaron has more videos that you can explore on YouTube, of course. Anyway, another subtopic we are going to see in this module, which is a very applied module, students like that, is plug and abandonment, the well at the end of its life. Plug and abandonment is a more important topic than what students perceive it is. The reason being is something that we see a lot in West Texas. We see that in areas where there is mature areas that are mature with oil and gas activity and more or less recurrent oil and gas activity. Like you have wells that have been plugged and abandoned. They were left like that for 35 years. And then somebody comes over next to those wells and starts a water flood. So the pressure builds up. Then suddenly those wells, the plugs in those wells fail, and the well starts spewing brine, for instance. Or even worse, starts spewing methane or oil, something that can contaminate the nearby environment. I think there is a trademark name for those wells. They call them zombie wells. And the why I say it's trademarked because it became a major topic in a past election for the Texas Railroad Commissioner. If you know, well, I don't know if we have people in the class from Texas, but you probably know from me, if you took other classes from me, that the regulating authority in Texas for oil and gas is the Texas Railroad Commission. So the Texas Railroad Commission has nothing to do with trains. It has everything and only to do with oil and gas activity. And we have an alumni from our department, a master's alumni. His name is Maxwell Bawa. He works for the Texas Railroad Commission. He is based in Midland, that area. He took this class from me the first time I was teaching the class in 2023. Very, very smart student, very, very good person, etc., etc. But anyway, the regulating activity is in Texas is done by the Texas Railroad Commission. The actual trains are overviewed by the Texas, I guess, Department of Transportation, and other stuff are regulated by the Department of Natural Resources or Office of Natural Resources. But oil and gas is made by the is regulated by the Texas Railroad Commission. And the reason for that is purely historic. Back in the 1930s, there was a problem with overproduction of oil. The Black Giant, it was called, the East Texas oil field was discovered in 1929. And suddenly every shipyard on the area became a driller. And they were producing like crazy, okay? And the price of oil was plummeting because of overproduction, oversupply. So they wanted an authority that had enough manpower to regulate, to control those shipyards who became drillers and force them to shut their production certain days of the week. They were forcing them to choke back production, basically. Shut in the well, let it produce only like a couple of days of the week, specific days. So in order to enforce their regulation, they had to have enough manpower. And the only entity at the time that had enough manpower was the Railroad Commission. So it became basically the Railroad Commission controls oil and gas activity in Texas. Their office is near the University of Texas in Austin. And the Texas Railroad Commissioner, back in the day, I don't know, it still is one of the most powerful people vis-a-vis oil and gas in the world. Actually, there was an old joke that a commissioner would go to work Monday morning and he would tell people, I will go to the office tomorrow morning, I will get coffee, I will sit down and decide what the price of oil will look like in the entire world for the next week. You know, it was an old saying, which was crazy. But yeah, this kind of wells coming back to life because the pressure going up, because somebody nearby doing some sort of either something that will raise the pressure of the reservoir, has been a big topic of discussion in the last two election cycles of the Texas Railroad Commission. So those positions, obviously, they are fought on the primary. It's like whoever wins the Republican primary is gonna be the next Railroad Commissioner. So they are fought pretty hard, and I don't approve of that, but there was a candidate that made herself tried to make herself famous on social media by climbing on a pump jack naked, without clothes, in order to protest against these zombie wells, as she called it, which was quite an interesting, I guess, situation back in the previous election cycle. But yeah, plug and abandonment is a very important topic. It's really the end of the life of the well, but yeah, you need to do it. Integrity matters, and it needs to be long-term integrity. There is a professor in Texas, a drilling professor, who has he made a consortium just for plug and abandonment. A very famous professor who Eric Van Oort. Anyway, plug and abandonment of a well involves plugging back a wellbore and temporarily securing it for a few months to years or permanently with an eternal perspective in mind. So it's like a champagne bottle. You have a cork, and the cork is holding pressure. Okay, you don't want the cork to fall. Now, the cork, as we mentioned previously in class, is a very special equipment, let's just say a special device, if we can call it a device. It has a negative Poisson ratio. So it swells both axially and laterally. So if you soak it with champagne or wine or whatever, something fluid, it will expand. It tends to expand in all directions. So it makes the seal stronger. So it's a good sort of feature, this negative Poisson ratio that it has. With wells, we pump cement of a certain height at certain specifications, or we would like it to be to honor certain specifications so that it will seal successfully for the long term. And the regulating agency, like the Texas Railroad Commission, dictates to a large extent those specifications. And since we're on the topic of the Texas Railroad Commission, every state in the US has its own oil and gas regulating agency, unless it's a state that doesn't produce a single drop of oil, I guess. Some states, they don't produce any oil, but they still have a regulating agency. North Dakota is unique in the sense that Laird, the namesake of the code library next door, he went to other states and learned what they would have done if they had the chance to put the regulating agencies before their oil discoveries. So he set it up before oil was discovered in North Dakota. And that's one of the unique features that we have in this state, is that we have data from almost every well drilled in North Dakota, excluding like one or two, the first ones. Everything else, because in North Dakota, the 26th well that was drilled was the one that struck oil. It was the in Tioga County, 1952. But you can find core data from that well if you go to the core library next door. So because those regulations were set in place before oil was invented, was discovered, sorry, in the state. In Texas, for instance, oil was discovered, then there was a boom, and then oil and gas, and then the regulating agency was created. It was a little bit of a different story. The regulating agency was chasing the producers and the drillers, you know? Yeah, and if you, I'm saying that because many of you could find a job in those regulating agencies, and if you ask me, something that will help you be competitive in that area, which wouldn't be a bad place to find a job at, is if you take the FE exam, Fundamentals of Engineering exam. right now at this stage of your academic higher education, you take the FE exam, you pass it, and then after you accumulate a certain amount of experience, you take the PE exam and you become licensed, board certified as a professional engineer. I would highly recommend you guys do that. Excuse me. If you look at the people working forget about the railroad commissioner who's an elected position. The people actually working for these agencies, you will find a lot of people with PhDs and board certifications, etc., etc. Plus, having this board license is going to help you a lot if you want to be consultant later on in life. And the FE exam it involves like a lot of stuff that you learn at school and you don't really apply it later on, sort of like electricity stuff, physics, thermodynamics, because maybe you get into an area that doesn't look at those disciplines, sub-disciplines, later on in life. So you may prefer that, I would prefer that you take it now, like between your junior and senior year. I'd be very, very encouraging in doing that. And I do regret myself not taking it the semester I was graduating. It was a crazy semester because I was trying to graduate early. But yeah, I would highly suggest that you guys do that. Anyway, enough digressions. In places where there is no national regulations, oil companies typically implement their own standard procedures for how to safely plug back a well or plug and abandon a well. Of course, your goal is to avoid leaks. And to avoid leaks, anticipating what kind of conditions this plug will face in the future. Okay. There is several techniques. You want to ensure that adjacent strata, particularly freshwater aquifers, are adequately isolated. In most cases, a series of cement plugs is set in the wellbore with an inflow or integrity test made at each stage to confirm hydraulic isolation. The well designer may choose to set bridge plugs like the one we see here, which is a man-made like devised plug, let's put it this way, in conjunction with cement slurries to ensure that higher density cement does not fall in the wellbore. In that case, the bridge plug would be set and cement pumped on top of the plug through drill pipe, and then the drill pipe withdrawn before the slurry thickens. So you basically run the drill pipe, you pump cement, and then you withdraw the drill pipe, and you let the cement there to set. And you hope that it will be enough to hold back any pressure increases that the well will face in its post-plug and abandonment life. A rule of thumb, economically speaking, is that there's an old school rule of thumb. I don't know if it's still the case. Could be. Is that let's see. When you plug and abandon a well, there are some equipment that you can pull out from the well that are not permanent, like some retrievable packers, etc., some liners. You can resell those equipment, of course, at a discounted price. There will be people that are interested in buying them. And it's expected that you are gonna make enough money out of that to cover the plug and abandonment expenses of the well. So many times, and some of you may be taking senior design classes, it might be a good assumption to make, logical assumption to make, is that the money that we are gonna take out from the what we are able to sell as a used equipment is gonna be enough to cover the expenses for the plug and abandonment. It's there is companies that specialize in plug and abandonment. When I was in Los Angeles a few days before COVID, we met some people on the airport. They were from Louisiana, and we were from LSU going to LA for a conference. They were talking to us. They were a company doing plug and abandonment. And there is a lot of wells in LA. And many of them are abandoned. Some of them are being reused because the drilling regulations are very strict. You basically cannot drill in California. Virtually, you cannot drill a new lease in California. And you are severely restricted from entering an existing lease even. Very, very difficult to do. But there are several, so they are trying to get as much as they can from existing wells. But there is a stage where you cannot get anything more, so you go and plug and abandon. There is companies that do that for you. And like I said before, there is a professor in Texas who is researching. It's not the only thing that he does, plug and abandonment, but he was able to put together a consortium, a research consortium for plug and abandonment. So these are serious stuff, you know. This is a serious subtopic. Some of you may get a job in this area. Again, it wouldn't be a bad job to have. Now, when it comes to well integrity, we are talking about the several ways this plug and abandonment can be compromised. This plug and abandonment configuration can be compromised. And here we have a very simple diagram that shows, no, it's not a simple diagram, it's a simple plug and abandonment schematic that shows a section of cement pumped down a well that is cased and cemented. And we see the various ways our plug and abandonment can fail. Okay, we see here something like 6 ways. Let me move this. 6 ways our plug and abandonment configuration may fail. One way is, so we have steel, cement, rock, and then another cement here. So it's the cement of the plug and the cement between the casing and the rock. So these are 2 different cements, and they're going to be very different type as well. So one way is that we can have flow in the interface between the casing and the cement. The casing and the cement between the casing and the rock. That there might be a microannulus there that can leak to fluid coming out of towards the surface. That's one way you can have wellbore integrity compromise. And this is mechanical degradation, like with stresses, like it cracks, a fracture basically. Microannulus is a fracture, it's a tensile failure. B, you can have interface on the where is it? On the other side, cement casing failure on the other side between the casing and the cement of the plug. It is possible. You can have fluid leaking upstairs through that. C is that you can have failure through the plug itself. The plug itself may not be good enough, may have cracks, may degrade over time, and fluid may be coming on the surface. Another way is leaking the casing itself. The casing is made of steel. So steel can be damaged in several ways. It can even degrade chemically by rust. It can, because the fluids underneath it may have sulfur or something acidic or CO2, it mixes with the water, it makes carbonic acid, it starts damaging your casing, the casing gets weaker, and then fluid starts going through the casing to adjacent layers next to it. That's one way, leaking the casing. Another way is leak in the cement between the rock and the casing. We call it the annulus cement. Like a lot of ways that you can dig a crack inside that cement and then you are losing fluid to the surface. And finally, interface between rock and cement on the other side. So these are 6 ways you can have 6 modes of wellbore integrity compromise from this system, which is pretty simplistic. I mean, it can get much more complex than this, but this is a very famous diagram that they made sometimes in the mid-2010s, around the time that I was in grad school, because I had a classmate who was working on plug and abandonment, actually, and at LSU, and he was using this diagram a lot, and sadly he wasn't able to finish his work because he tragically passed away in a ridiculous car accident. That wasn't his fault. Anyway, that's a sad story. But several ways you can have your well integrity of your plug and abandonment setup compromised. Speaking of, I guess the old research group I was part of in Louisiana, our advisor, Dr. Gupta, she recently received a grant to investigate methane leakage from abandoned wells in Louisiana, which is not a very different idea from what I've been discussing now. There is several wells you can go next to them, and they are abandoned, they are plugged and abandoned, but you hear shh because of the methane coming out of the well, leaking. It's easier to leak gas than liquid, obviously. I mean, we talked about the zombie wells in Texas spewing brine, but methane can be more dangerous because methane is flammable. Somebody can be nearby, try to light a cigarette, he doesn't know what is going on, and suddenly he turns into, engulfed into flames, It can be very dangerous with methane. It's basically natural gas. Very flammable. If it's CO2 that is leaking, it's not that bad. The problem with CO2 is if you have a blowout in a CO2 injection well, you cannot really burn the CO2 because it's not flammable. If you have a blowout in a natural gas well, you can flare the methane there by burning it into CO2. So it's a little bit of a different kind of problem. But methane leakages from wells, it's a big topic as well as brine leakages. Basically, for us, they are all wellbore integrity compromises. And these are this picture, I believe, summarizes very well the main ways you can have leakage. I don't know if you saw that in geomechanics, but when I was teaching geomechanics, we discussed about microannulus creation. This is achieved when the radial stress is basically, just like we said, if the tangential stress overcomes the tensile strength of the rock, you get longitudinal failure. If the axial stress overcomes the tensile strength of the rock, you get transverse failure. If the radial stress overcomes the tensile strength of that interface, particular interface, you get microangulus creation. It's the same way. You investigate, not investigate, you try to quantify. That is the pen. Always use green for the, okay, very good. Always use green for the radial stress. So let me use green and say radial stress becomes more tensile than the tensile strength of that interface, which would be either here or here or here. And then you get separation. You get like, they are pulled apart from each other. And you get microangulus when this criterion is satisfied. Appropriate barriers have acceptably low permeabilities, same or lower than the cap rock permeability. The rule of thumb is that you want to be between a nano-Darcy and a micro-Darcy. Nano-Darcy is less than the permeability of shale. Several shales have higher permeability than that, and they are considered low permeability. It's basically glass. From historical industry experience, as a rule of thumb, 100 feet of good cement with permeability less than 10 microdarcies should be sufficient, or should be considered sufficient. That may not always be the case. That may not always be the case. Now, if you are in an area where the plug and abandonment regulations are very strict and very, very well defined, if they basically dictate how you do plug and abandonment. So if they want like 200 feet of cement that you can test and give you specific results, I mean, this is the procedure that you need to follow. And finally, module 2 summary. We learned about the main completion types. We did routine pipe calculations. For some of you, this was a revision from other classes that you took with me, that we did routine pipe calculations. We talked about typical wireline operations. It was a bird's eye view. We talked about perforating and spotting acid. We talked about basic sand control techniques, how to keep sand away from your well. Sand production is a big, big headache for several operators. And we talk about multi-stage hydraulic fracture stimulation basics to set the stage for the next module, which would be heavily on hydraulic fracturing. We needed to have some basic understanding of the operations, of the relevant operations, of course. And finally, we discussed plug and abandonment integrity. Yeah. And that was module 2. 69 slides. Any questions on module 2?
Just about the plug and abandonment question.
Yes, sir.
So, for example, oil and gas division dictate the regulation for the plug and abandonment, or it's the company who own the production well?
Both. The answer is both. If the regulating agency, if there is a regulating agency in your state, and it has specific rules for plug and abandonment, your company has to follow those rules. But on top of that, your company has protocols. and they may add to those rules. You know, whatever protocols you are following, your company is following, should at minimum satisfy the rules of the state, right? And beyond that, it's basically depends on the company policy.
Okay, thank you.
Yeah. For instance, you are in Ohio. Ohio has long oil and gas history. So I don't believe, without knowing, Ohio should be having fairly diligently written plug and abandonment regulations. They are not considered laws, they are considered regulations. Like the law is that you follow the state's regulations, right? So if you basically don't follow the state's regulations, you're breaking that particular law. But then your company may have its own sort of procedures and protocols that may go further than those regulations. For instance, if the regulation is calling for 100 feet of certain grade cement pumped, and then you test them in a certain way and providing this kind of results, your company may mandate for 2 times that or for 3 times that. It really depends. It really depends. And let's not forget that Standard Oil was founded in Ohio, Cleveland. So there is history from the 1800s in your state. So it would be. I expect the regulations there to be fairly, elaborate. So, any other questions on Module 2? Okay, so exam 2, which will be sometime next month, will basically cover from slide 21 of Module 2, which is where we start with Packers all the way to where we make it by the second exam. And there are some things that are not that important, and I will discuss that when the time comes for review for that exam. But there are some things that we went by very fast, and it was intentional because I know that you are seeing them in other classes as well. I don't expect you to know this stuff in very much detail. I would be very indicative of what things you need to know pretty well. Okay, so now it's time for us to start Module 3, which will be the biggest and arguably the most important module we are gonna go over in this class. And I believe it's gonna be very interesting to you guys. Hydraulic fracturing operations. Virtually every well drilled in the US today is being hydraulically stimulated. It's almost part of the manufacturing process. Like every well that is being drilled will have to be stimulated at some point in its life. And I will tell you from my not very elaborate experience, it's better to do it early. It's better to stimulate the well as early as possible. It gives you some benefits versus than producing and then going later after a couple of years, 3 years or something, to stimulate. It's better if you do it early. Besides drilling, hydraulic fracture costs are the second. Drilling costs are the biggest, and then is the biggest chunk of money that you are going to spend on your well. Obviously, to drill it, you have to get a rig there and do the drilling. It's a big operation that takes like 85 to 90% of the cost, I believe. And then a big chunk of that, the remaining 10%, will go to hydraulic fracturing. and then the rest is gonna be workovers, lease operating cost, etc., etc. I think over the years, the dynamic has been the drilling costs were reduced a little bit and the hydraulic fracturing costs were increased. And that was, it had to do basically by demand and supply. The companies that do hydraulic fracturing in the US, they have to cover pretty much all the wells drilled in the US. So there is a lot of competition between operators to get those service companies, especially back in the day of high oil prices when I was undergrad. Oil companies were like service companies, operators were competing for the service companies. When the price of oil collapsed in 2014, you didn't want to be in a service company. Anyway, good days before the oil collapse. In conferences, service companies will throw parties. They will invite our professors. The professors will take us with them. It was crazy. Anyway, fracking. Why, how, and for what? You may hear that in the news, particularly in the last decade. And you may also have heard it by different, I guess, interest groups, either advocating for it or being against it. And they use the word fracking, and there is people debating whether you should have K in fracking or leave it without K, because there is no K in fracturing. And fracking was a little bit of an unfortunate nickname, as I can say. But anyway, I personally think that whether we like fracking or not, we should be writing it the same way because we are all talking about the same thing. But that's just a personal opinion. I know people put frac and then apostrophe and then ing, like the Secretary of State, the Secretary of Energy, who's a founder of the biggest company, fracturing company in the US, Liberty. The biggest, like, solely fracturing company, a service company that only does hydraulic fracturing, is like Liberty Oilfield Services. Is based in Colorado. And they started in 2011 by a bunch of people who had experience in hydraulic fracture modeling before. They used to be working for a company called Pinnacle Services or something in San Francisco, in the Silicon Valley, and they were doing hydraulic fracture modeling. And those were amazing people. Lynn Wires, who's the former vice president of Liberty Energy, he recently retired. He has the best PhD thesis I ever read on hydraulic fracturing from Delft in 1995 in Netherlands. He did experiments, computational modeling, analytical modeling. It was like tremendous amounts of work done for his project. And he came over to give us his talk 2 years ago. And I have a student who is working on a similar topic, Nassim, who used to TA, I believe, this class a couple of years ago. And he gave him a copy of his dissertation and signed it for him. So Nassim was very happy because his topic is very, very similar to what Lynn Byers was doing. He's a very nice guy. He even took us out for dinner. He knows the area very well because when they were, and these people were all people with PhDs and grown families, when they started the business, they were out in the field doing the job, like they were supervising a frac crew, etc., etc. So these are people who really know what they're doing from both theoretical and applied perspectives. Very, very smart people. Now, why do we do fracturing? Why do we fracture a well? And the reason is to stimulate the production, make it produce more. Okay. Now we create some fractures from the perforation tunnels that we mentioned earlier by pumping fluid, and we keep these all fractures open using high permeability sand called propan. Propan is like what props the fractures open. That's why it's called propan. For the people who don't speak English as their first language, me included, that's what the word propan, it props open the fracture, keeps them open. Because when you remove the fluid pressure, the fracture wants to close. You put the propan there and it keeps it open. Now, propan technology is a very, very big part of the industry as well. The 2024 SP president works as a technology vice president of Carpo, which is a big propan supplier for the hydraulic fracturing companies. By the way, I'm not 100% certain, but I believe when these people that created Liberty left Pinnacle, their software was bought by Carpo, I believe, because Halliburton bought the company, except that software, which went to Carpo, if I remember well. So they are all related on the history of hydraulic fracturing, I guess, or modern day history. So you have a rock that has oil in it, but it looks like glass. It has very low permeability. So you go in, you pump fluid, you crack it, you put something in those cracks to keep them open, and you try to produce fluid from there. This is why we do it, this is how we do it, and we do it to make more production and make more money, obviously. Now, historical background. Fracturing has a longer background in terms of history than what you would expect. It actually goes back to the mid-1800s. That's when people used to drill, people had wells. Obviously, they were drilling. They started drilling wells in 1859, okay? By 1863, there was a boom. They were producing like crazy in Pennsylvania. And by 1865, the area was depleted, and people were talking that there is end of oil. There is no oil. We're running out of oil by 1865. And they still talk about, some people still talk about that today. The thing is that back then they understood that if you go there, you can go there with explosives, shoot them down the well, and create a small explosion at the bottom of the well, and that can temporarily increase production. This was done with torpedoes. And there was a lot of technology done back then in relation to that. And I will show a picture of somebody here. And Shamel, do you know who that is? No?
Maybe Schlumberger brother?
Say it again?
Schlumberger brother?
No. Actually, American students know this person. This is actually the guy who assassinated Lincoln in 1865. His name is John Wilkes Booth. So during the Civil War, the U.S. was divided into South and North, and Abraham Lincoln was the president, and he got assassinated in an auditorium, in a theater play. Somebody went on stage and shot him, and it was this person. Now, the reason why I'm putting the picture of this person, people don't know he was an actor, but actor was his hobby. His real job was to torpedo wells for basically to stimulate production. So he was doing oil and gas. In fact, his company was called Dramatic Oil because he liked drama, he liked acting. So that's somebody that people don't, he's very famous in America, but he's not related to oil and gas as much as he spent a big part of his life in oil and gas, actually. But that was back in the 1800s. People would torpedo the wells in order to improve the production. And there was some gains that were made, but not very sustainable. In 1929, in Texas, Texas, the first horizontal well was drilled by somebody, ironically, called Robert E. Lee. The thing is that during that Civil War, the general of the South, the Confederates, he was called Robert E. Lee, but it's not the same person, you know? So anyway, there was a patent that existed for drilling a horizontal well from the 1890s, I believe 1891. But the first actual horizontal well was drilled in 1929. The horizontal well helped a lot with having more surface area of the reservoir exposed to the wellbore. Now, in 1947, in Hugoton Field in Kansas, there was the first hydraulic fracture job, in a sense that hydraulic comes from fluid. Fluid was used to stimulate the well because torpedoing the wells was stimulating production. It was a reservoir stimulation process, but it didn't involve fluid, right? But in 1947, they used napalm, interestingly, and they stimulated the wellbore, the well there. I will show you a picture of that later. And they basically, it would be the first time a process called hydraulic fracturing was used. In fact, I think it was called hydrofracking back then. If I remember very well, a very famous paper that was published 2 years later, it was describing in SPE something called hydrofracking by Clark. In 1949, it was the first commercial hydraulic fracture job in the same field. Okay, so the well was vertical, but they used fluid. They pumped it at very high pressure to create fractures and basically stimulate production. They didn't use any propane or anything, but you can say, literally speaking, it was a hydraulic fracture process. Now, in 1982, here is the catch. There was a very, very smart graduate of petroleum engineering in Texas A&M University. He graduated first in his class, and I think he had a perfect GPA. And he was smart like some of you guys, and he went on to build his own company. He was from Galveston, and he was a kid of Greek immigrants. His name was George Mitchell. George Mitchell the Mitchell was a made-up name because he had a long Greek last name, and the mailman he couldn't understand the last name and he couldn't read it. So he tried to simplify it to make it simpler for, I guess, everyday life. So anyway, this petroleum engineer had the idea, because back then they were drilling through shale, and they knew that shale has oil, but they didn't know how to produce the oil from the shale, because cores will come to the surface of shale. It will be like glass oozing with oil. You have oil coming out of it like oozing out and be like, I wish I could produce from this rock, you know? That's where oil is made. It's low permeability. I wish I could produce it. It would have been a great idea. So this guy, George Mitchell, I think he got a contract to sell natural gas to the city of Chicago around that time. So he was trying to find a source of natural gas. And he kept looking at this shale and he was like, I wish I could produce from it. And then he thought about it. Okay, there is two existing technologies, hydraulic fracturing and horizontal wells. What if I combine those two to do something, apply it to this low permeability rock? So it took him about 17 years of trial and error. And this was a very smart guy. People were telling him, stop wasting your money on this. And he would tell them, it's my money. I can waste it the way I want to waste them, waste it, And he eventually perfected that technique. And in 1997 was the first treatment with slick water, which is basically what we call today hydraulic fracturing, which the videos that we saw in the previous module from Aaron Barton, it's very similar to what we call today hydraulic fracturing. So in 1997, he had this big success in first treatment with slick water. And it was run by somebody called Nick Steinsberger, who by his own admission was a grade C student at the University of Texas. He had graduated. He didn't have a job. He went backpacking in Europe. He came back. He attended Career Day in Texas. He got hired by George Mitchell. And then a few years later, he did the first slick water fracture treatment, which was very successful. And that led to the shale boom in the Barnett Shale. All of them now are very rich. Nick Steinsberger's son was a student in University of Texas a few years behind me, like 5 years behind me or something. We never really interacted because I was already in grad school when he came over. But those people are they made a lot of money out of the whole process. Anyway, by the way, George Mitchell was very old at the time. He died in 2013 at the age of 94. If you know the residential area in the suburbs of Houston that is called the Woodlands, I was there last month for the hydraulic fracture technology conference. The Woodlands was created by George Mitchell. And the reason it's called the Woodlands is not because of the trees. It's because of his in-laws. His wife's name was Cynthia Woods. So that's why he called the town there the Woodlands. He also gave a lot of money to the astrology department in A&M. He was a big philanthropist. They make a lot of money, all of them who worked with Mitchell Energy. Because Mitchell Energy was eventually bought out by Devon. And of course, the Barnett, it led to a boom in the Barnett Shale in northeast Texas. And that eventually led to the boom in the Bakken here and other places in the US like the Marcellus, et cetera, et cetera. So this is a very important guy. And the funny thing, or the most interesting thing, is that he did not invent anything new. He just applied two existing technologies to unlock a problem, an existing problem. So he didn't invent anything new. And, it took him, there is books that you can read about him. one nice one is called the frackers, and another interesting one is the boom. But I think he's mostly mentioning the frackers. There was like people were taking them to the court, etc., etc. Long stories. In some case, somebody was going to the court and he had a heart attack on the way to the court, and because of that, things change, etc., etc. So it's a very interesting story, and it leads us to where we are today, where hydraulic fracturing, horizontal well and hydraulic fracturing is basically our bread and butter. Okay, I think I will stop the class here, and we'll go a little bit more technical on Thursday about this process. It's going to be a nice module. You are going to enjoy it. So thank you very much. Remember, office hours will be shortened tomorrow. And any questions on the exam, please reach out to the TA first. And then if there is still an outstanding problem, come to me. And yeah, if you have any question or you want to meet, despite the shortening of the office hours tomorrow, please shoot me an email and we'll arrange something. Thank you very much. Have a nice rest of your day.
Thank you, Professor. Have a good day.
Thank you, Shamil. See you.